Hello friends, welcome to the spoken tutorial on Firebird 5 robotics research platform. This platform is based on Atmega 2560 microcontroller, which belongs to AVR architecture based microcontroller family. In this tutorial, we will learn the basic I/O interfacing on Firebird 5 robot. What are ports? Ports can be defined as junction where peripheral devices can be connected. Peripheral devices can be classified firstly as input device. Input devices are the devices which give signals to the microcontroller. So example of input devices are switch, sensor, etc. Other peripheral device is called as output device. Output device are devices to which the microcontroller will send the signal. Example of output devices are buzzer, LCD, motors, LEDs, etc. Let us now see the ports present in Atmega 2560. So Atmega 2560 is a 100-pin microcontroller, out of which 86 pins can be used as input or output pins for I/O interfacing. These pins are grouped together and are called as ports. The pins are called as ports because if you want to access any of the peripheral devices, you have to do it by putting the address of it, that is to which pin particular input or output device is connected. So addressing 86 pin is very difficult. So we have grouped the pins and have called them as ports. In Atmega 2560 we have 10 8-bit ports named as port X, where X is the name of the port, and X will vary from A to F and H, J, K and L. Atmega 2560 has one 6-bit port which is named as port G. All ports can be configured individually as input or output pin as per the device connected to it. Now let us see how to access the port. In AVR architecture, each port has 3 registers associated with it. So we have to use these 3 registers to define each port which we are going to use. The first register is DDRX register, where X can be replaced by the name of any of the port register, that is A to H and J, K and L. The second register is port X register, and similarly we have third register which is called as pin X register. So now let us study each of the register in detail. So first register is DDRX register. DDRX register stand for data direction register. The purpose of this register is to set the port pin as input or output. If we assign the value 0 to DDRX register and we set the port pin as input pin, similarly if we assign the value 1 to DDRX register, we set the port X pin as output pin. Let us see an example for getting more clearer concept. Suppose we need to make port B lower nibble as input and upper nibble as output. So for this, what should be the logic? Logic for it would be to assign the value 0 to the port pin D0 to D3 and value 1 to pin number D4 to D7. We represent the value in hexadecimal notation, which will give convenient and standard notation while programming in C language. So here the value is written as DDRB is equals to 0xF0. Now let us consider the pin X register. The purpose of this register is to read the value from the input device connected to the port pin. If we define a port as input port, then we read the values present on the input devices using the pin X register. The value read from the pin X register is to be saved in a user-defined variable. Let us consider an example. Suppose we have declared port C as input port, that is, on all pins of port C, some input devices are connected. For this purpose, we have already defined DDRC is equals to 0x00. Now, suppose that on all these input pins, I have connected a switch. So, and say that out of those 8 switches connected on pin number D4, D5, D6 and D7 are pressed. So as soon as the switch are pressed, the pins will read a status high. So the voltage level will go to 5 volts and the pin will read a logic high. So in order to read whether switch is pressed or not, we are going to use pin C register. So we use pin C register and store the status which is of the pin in a variable, and later on use this variable for further manipulation. So in this case, if we use say any variable x and we use x is equals to pin C, so it will give us an output x is equals to 0x f0. So here f reads the status of the switch as 4 switches are pressed from D4 to D7. So we are getting a logic high on those pins, and switches on D0 to D3 are not pressed, so we are getting a status as 0. Now let us see the third resistor, which is port X resistor. Port X resistor operate in 2 different ways depending on the way in which the port is defined. First case is if port is defined as the output. We use port resistor to output desired value to the output device. For example, here we defined port A as output by assigning the value DDRA is equals to 0xFF. In this case, if we assign the value as port A is equals to 0xFF, which means the logic high to the device connected to port A. Now suppose if the device is LED, then the LED will glow on the logic high. Similarly, if port A is written as 0x00, LEDs will turn off. Now let us see the second case. In this case, when the port is defined as input port, in such case the port X resistor is used to activate or deactivate the pull-up resistor. So what are pull-up resistor? Pull-up resistors are used to assure that the input to the pin is maintained at a desired logic level, even if no active devices are connected to it. This is done to avoid any external noise or interference to our reading, and hence to minimize the error. So to activate the pull-up resistor, we assign the value as port X is equals to 1, and to deactivate it, we assign the value as port X is equals to 0. Let us consider an example now. In this, we make port A as input port using DDRA is equals to 0x00. Then to activate the pull-up, we assign port A is equals to 0xFF. So the pull-up resistor is activated for all the pins of port A. So with this, we have come to the end of this tutorial. Thank you for listening.